hopefully you will see a little bit of connection to matrices with what we've talked about before. Only like one connection. But it seems very different, okay? And some of you may need a little change of pace, right? So chapter 8, here it is, okay? Now, what is a matrix? Yes, Matrix is a movie, but how many of you have actually seen The Matrix? Yeah, it came out when I was in high school. That's how old that movie is. So I guess that's considered a classic now. I don't know. All right, that's what this graphic is from. How many people know that there's a movie called The Matrix? Okay, so I'm not completely like throwing you off here. Okay. A matrix is a rectangular array of numbers. Numbers in brackets. Like this. It looks kind of like a table of numbers. Okay, so the brackets, we're going to put those around all of our matrices, okay? And then we have numbers, organized in rows and columns, would be a good way to describe it, right? Each number is called an entry. And then we like to describe the size of our matrix, okay? And that is called the order. Okay? And we describe the order of our matrix as the number of rows by the number of columns. 5, 0, 2, -2, -7, 4, those are all entries of our matrix. How many rows do we have in this matrix? We have 3 rows. Gabe, how many columns do we have? 2. Okay, since we have 3 rows and 2 columns, then we say that the order of this matrix is a 3 by 2. This is a 3 by 2 matrix. If I call something a square matrix, what do you think is true about it?
Same number of rows and columns.
Same number of rows and columns. Pretty intuitive, right? Now, since a matrix is something that you have probably never seen before, unless you came from algebra 3, today is full of lots of terminology. Okay, on the next slide, there are going to be 4 matrices. I would like you and your group to work collectively on identifying the order of each matrix. Remember, the order is count the number of rows by count the number of columns. Okay, here are our 4 matrices. I want you to identify the order of each with your group. So I'll give you a moment to write them down if you wish.
So if, like, by any chance, any of those happen to be square, do you need to say that it's square, or do you just say the order like you would if it was rectangle?
You just say the order like you would. I bring up the point of a square matrix because we will get to a point on Thursday where only square matrices have certain properties. So I just wanted to bring it up now. Okay, so as a group, please identify.
Hey, number G is the example.
Oh, is it? Whoops. You already know that answer. Oh.
That can count. You're gonna have a really successful assignment.
All right, pod 3. What is the order of A?
One by one.
Do you agree, pod 1? Excellent. Pod 6, B.
1 by 4.
Pod 5, do you agree? Awesome. Who did I just ask? Pod 6, right? Pod 2, C.
2 by 2.
Pod 4, do you agree? Excellent. Pod 1, last one.
3 by 2.
Everyone, do you agree? Excellent. Now, you're all saying, man, this seems really easy. Don't forget it. Okay? Don't forget that it goes rows by column. That is a very important thing to keep straight. Okay? All right.
Spit them up first.
Now, on Wednesday, we will work with adding, subtracting, and multiplying these matrices. Okay? But before we do that, I want to tell you what some things that we can do with one matrix by itself. Okay? We can actually, and here's our connection to chapter 7, we can actually use matrices to assist us with systems of equations. Okay? We're going to write an augmented matrix. And an augmented matrix is a matrix that we write from a system of equations. So I'm going to give you an opportunity to go ahead and copy down this system of equations. And what we are going to do, we are going to put this in a 3 by 4, what we call augmented matrix. Okay? Now, what's nice about matrices, it is a rectangular array of numbers, right? We're not going to worry about putting x, y's, and z's. We're just taking all of the coefficients and plopping them into a matrix, essentially. Okay? So our augmented matrix for this, okay? Basically, the first row is going to represent all of the coefficients for x. The second, excuse me, did I say row or column? I meant column. The first column is going to represent all of the coefficients for x. The second column is going to represent all of the coefficients for y. The third column, z. And since we only have x, y, z, the fourth column will be our constants at the end. Okay? So our first row is going to be 1, -4, 3, 5. Our second row is going to be -1, +3, -1, -3. And our last row is going to be 2, 0, -4, 6. Okay? And since we're using a system of equations, we make these dots where we would have those equal signs to separate our the numbers that represent those variables versus the numbers that are the constants. This is an augmented matrix. I would like you, first of all, any questions how I got these numbers? Why is this a 0? There is no y. We have to account for it. Great. So this system of equations, I would like you to write an augmented matrix for it.
Is there a reason there's a dot by anything?
I think I copied this and it was like the end of a sentence.
I didn't know if there was gonna be like some catch or something.
No, it's not possible. Write as big as you can. Very simple. Do you agree with Ryan's augmented matrix?
Yes.
Yes. Any questions? Okay. If you had two equations with two variables, what would be the order of your augmented matrix? 2 by 3. Okay. In your homework, I'm going to ask you to write. You're going to be asked to write augmented matrix. Make an augmented matrix for both 2 variable systems and 3 variable systems. Okay. Now, we're going to talk about augmented matrices. We're going to talk about row operations. We're going to practice both of them, and tomorrow we're going to combine the two. Okay? So what can we do with a matrix if it's just by itself? Okay? We have 3 operations that we can do. We're going to talk about the first one, we'll go to lunch, and we'll talk about the second 2 after lunch. Okay? So there are 3 row operations that are quote-unquote legal in mathematics when we are dealing with matrices. Go ahead and write down the 2 by 3 matrix of 1, 2, 3, 4, 5, 6. Okay. Anytime you perform a row operation, it would be my preference that you notate what you did so I can follow your work. It is legal to interchange 2 rows. So we can take row 1 and switch it with row 2 and have the matrix 4, 5, 6, 1, 2, 3. That is legal. all we did basically is reorder our rows. If we are looking at this as an augmented matrix, right, our equations are still the same. When we get back from lunch, we're going to talk about the second and third operations, and then we will practice them. Enjoy your food.
Data row operation.
All right. Elementary row operations. It is legal for us to switch or interchange two rows to make sure everything in one row stays together. It is also legal for us to multiply a row by a non-zero constant. So we can take any row and multiply it by a constant. Remember, if you do a row operation, I would appreciate you notating what you're doing. So we can take, let's say, row 1 and multiply it by -4, which would give us -4, -8, -12. 4, 5, 6. And then last but not least, we can add a multiple of a row to another row. This is the one you'll probably use the most when we get into tomorrow's topic. So, on the next slide, I'm going to tell you about a couple forms that we have. There are going to be times where we want certain numbers to go to 0 and certain numbers to go to 1, okay? And so what I'm going to do here to demonstrate this one is I'm going to take row 1, multiply it by -4, and add it to row 2. Okay. So I'm going to keep row 1 as 1, 2, 3, but then if I imagine multiplying row 1 by -4 and adding it to row 2, I have -4 times 1 plus 4, -4 times 2 plus 8, and -4 times 3 plus 6. So we get that. Like I said, we're going to practice row operations today and then use them tomorrow for an end goal. Okay? Now, these all look different, but if you are using these row operations, then the matrix that you get after you've done all of these row operations is still what we call row equivalent to what we started with. Okay? The two matrices, or any of the matrices as you're working with these row operations, okay, they don't look the same, but they're still row equivalent. Okay, we can get back to them using the same operations if we wanted to. So we're gonna practice this. On the next slide, I have a matrix. I want you to go ahead and copy it down. Okay, I'll read them off to you. If you want to listen, you can. Okay, the first row is 1, -4, 3, 5. The second row is -1, 3, -1, -3. And the third row is 2, 0, -4, 6. Okay. There's going to be a couple of problems in your assignment tonight that ask you to do specific row operations. Okay. The first one that I want us to perform is to switch rows 2 and 3. So row 1 is going to stay the same, and then we're just going to flip-flop places with rows 2 and 3. So we have 2, 0, -4, 6, and then -1, 3, -1, -3. From here, I'm now going to give you the instructions to take row 1, add it to row 3, and replace that sum with row 3. Do you see my notation? Row 1 plus row 3 and replace row 3. Does that make sense? That notation? So that means row 1 and 2 are going to stay the same. Row 1, add it to row 3. So 1 plus -1, -4 plus 3, 3 plus -1, and 5 plus -3. Okay. Why are we learning about these row operations? So the next set of definitions that I will show you involve a certain type of form for these augmented matrices. Okay, there's 2 different ones. The first one is called row echelon form. Okay. This is what row echelon form looks like. Any row of zeros will be at the very last row of your matrix, be at the bottom of your matrix. All other rows, the first non-zero entry is 1. And then if a row has a 1, the row above it with a 1, it would need to be further to the left. In blue, I have written up an example of row echelon form. There doesn't have to be a row of zeros at the bottom, but if there is, that's where it goes. Okay? Now, notice how, like, the second and third row, they have zeros, and then the first term, the first entry that is not a zero is a 1. And then notice as we go from bottom to top, the ones keep going to the left, okay? I kind of like to describe this as we have a diagonal of ones, okay? And then anything underneath that diagonal of ones has to be a 0. An even better form is reduced row echelon form, where zeros are above and below any leading one. An example of this let's talk about why these forms are nice. And we'll start with reduced row echelon form. If this is our augmented matrix, what does this first row mean? X equals 5. What does the second row mean? Y equals 3. And the third row? Z equals 7. If you can get a matrix into reduced row echelon form, you have the solution. That's cool, right? Okay. Let's talk about, is this the one that I wrote up? Oh, that would have been a better idea, huh? Okay. Let's talk about this augmented matrix. Amanda, what does the first row mean? What'd you say? Okay, so what do we do with that -1 and 2? Okay, I like that better. X minus y plus 2z equals 4. Okay. What does the second row mean, Sarah?
Y.
And the third row, what does it mean, Finn?
Z is equal to -2.
Okay. Jackson, these are your favorite type of 3 systems, right? I remember you talked about this the other day. Okay? Easy to solve from here? Z is -2. What do we do with that? Go back up 1. Y minus -2 is 2. What is y? Okay. Go back up to the first equation. X minus y plus 2z equals 4. What is x? So the solution to our system is 8, 0, -2. Okay. So today we've covered the basics. Okay, what is a matrix? How do we identify entries in order? What is an augmented matrix? How do we work with row operations? You're going to practice all of this tonight. Tomorrow, we are going to start with a system, write it as an augmented matrix, and I'm going to show you how to do row operations until we get something like that, and we can figure out what X, Y, and Z are. Okay, that's where this is going. Okay, but tonight we just need to practice the basics. So, this is your assignment. I do have a gold sheet for you, so you can either choose to write this down or wait for your gold sheet. And it looks like we have some time in class, so I would encourage you to get out your book. You'll probably have to share some books if people don't have them with them. And go ahead and start on this assignment. Now, tomorrow I'm going to show you how to do some matrices with your graphing calculator, so please bring it.